Okay. Good afternoon, everyone. I welcome to I welcome everyone for 91st episode of Creative Online Talks. Myself Supriya Naika hosting this program. Creative. Creative means creativity. To be we need creative things. So creative things keeps us active. That meaning of creative. Creative is a group of people who are eager to gain new knowledge. Creative tagline is knowledge square. Sharing of knowledge increases our knowledge. Creative vision is to build constructive thinking on various domains, and our main focus on non-textual, non-academic, non-syllabus related concepts. Every Saturday we organize on weekend online talks on Zoom platform, and also we live streaming our program on Creative YouTube channel, Creative GBD. And we are very thankful to all our resource persons for engaging us with their knowledge and sharing their knowledge with us. And today's topic of creative is the intricate world of environment and climate change. To present this, we have Dr. B.C. Prabhakar sir with us today. I welcome you, sir, and I welcome everyone for today's session. And I call Brinda, creative volunteer, to introduce today's speaker. Over to Brinda.
Thank you, Supriya ma'am. A very good afternoon to one and all. I heartily welcome today's speaker, Dr. B.C. Prabhakar sir. Sir is a professor of geology at Gulbarga University till 22/3/2021. From 23/3/2021 till today, worked as a department of geology, Bangalore University. Sir has been a chairman for the Department of Geology, Bangalore University from 2004 to 2006. Sir was also chief custodian for PG examination of Bangalore University. Sir was a nodal officer for KSET examination of Bangalore University. Sir successfully guided 8 PhD students, 8 MPhil students, presently guiding 3 PhD students. Also successfully guided 21 dissertation work. Sir successfully completed 4 research projects funded by DST, UGC, PRNS University. Research journals like Geological Society of India, Mineralogical Society of India, special volume of the International Dike Conference, Journal of Applied Geochemistry, episodes, International Journal of Engineering of Earth Science, Journal of Earth System, SCS series Springer were like. Sir has also delivered 45 invited lecture keynote address at various forums, seminars, and served as a resource person for HRDC. Panelist in 12 different TV programs on the issue of conquering earthquakes, environment, and geological issue of public concern. Sir published 53 research papers, published the review of 2 books, published the review of a special volume of ISAG on exploration and a research on atomic minerals, published 2 reports on 2 national seminars, also published 22 articles of public scientific interest in a newspaper and special volumes. Thanking you. Over to Supriya ma'am.
Thank you, Brinda. Prabhakar sir, Brinda is from Gulbarga.
I see, very nice.
She is studying in 8th standard, sir.
Oh, nice.
Okay, sir. Over to you, sir. You can share your PPT.
Sure. Okay. Firstly, let me thank Supriya for giving a chance to speak in this creative forum. And I also thank Brunda for telling some nice words about me. Just a minute. As Supriya was telling, today I am going to deliver a talk on the intricate. Hope can you see my slide?
Yes, sir. It's visible.
Okay. the intricate world of environment and climate change. You all know that today we are in a world where every day one or the other natural event takes place, and people blame climate change for it, whether it is flooding, whether it's an avalanche, whether it's some kind of global warming or any issue. We all point at climate change. And environment is so closely associated with the climate change. Rather, the change in the environmental domains lead to climate change. So I thought that it shall be a subject for all the college, school and college students, as well for researchers, faculty members. I try to share my views on this. Intricate is very delicately webbed. That is the meaning of intricate.
Sir,
Very,
sir, one minute. Can you keep your slide in slide mode, sir?
Slide mode. Okay. Is it okay now?
No. Yes, sir. You can
I
continue.
think,
Thank you, sir.
yeah. So I thought I shall share my views on this environment and climate change. Well, let us start from basic things. What is environment? So environment is all about the natural embodiments that surround us. What are those things which surround us? A variety of materials or mass in atmosphere, biosphere, hydrosphere, and geosphere. I'm sure you are all familiar with this atmosphere, biosphere, hydrosphere. Geosphere is all about the soil, different types of rocks, and different variety of weathered profiles, which in one way or the other, so closely related with atmosphere, biosphere, and hydrosphere. So put together, this constitute our environment. So you wake up in the morning, you see the sky, there is air. You see the other way, you have water. But hydrosphere, biosphere is about life. And if you see a rock or something else, it's geosphere. So we cannot escape from these four spheres. So this constitute environment. And what is climate change? The adverse impact on environment affects the composition of atmosphere. That leads to climate change. So there has been a continuous impact on the environment because of so many factors that we are going to discuss here afterwards. So that leads to change in the environment and change in the climate. So in the long range, this climate change affects everything. We should first of all understand why this is happening. The first and foremost, to me, why environment is affected, why climate change is affected, is due to development. So today we are living in a world where there is a lot of debate about development versus environment. What is development? We every day, every time, ever since the civilization has been happening since several thousand years, we are striving ourselves to create better living standards. So if you have got 1,000 rupees, you want to increase it to 1 lakh rupees. Those who have got 1 lakh rupees, they want to make it 1 crore, those to 1 crore, to like that, this goes on. Better and better standards we set ourselves. So this is happening on one hand. On the other, we also need to mind about providing basic sustenance. Still in this world, there are countless people who do not have basic sustenance like food, shelter, clean drinking water, like that. So this is our fundamental responsibility to provide the basic sustenance. So this, all our activities in this direction constitute development. If you build a building, there is some meaning for development. If you develop a rocket, there is some development. If you develop some electronic device, there is some meaning for development. So this civilization and development are going hand in hand. This is one aspect. And at the same time, we have to care about our environment. The environment that we just discussed, that is, the four spheres have to be protected. Why is it happening? Because development means more demand on resources. So why this more resources are consumed? Because there is growing population, ever growing population. This is an interesting statistics for you. So in 1900, global population was 160 crores. And now it is 780 crores. You can see how manifold we have increased ourselves. If you consider India's population, we were just 24 crores in 1900 and now 138 crores. And the global projection is 960 crore population will be there by 2050. And India will have 165 crore. You should know that India was in second position as far as population is concerned, and now we have beaten China in population. We have already overtaken China. Therefore, this manifold increase, rather explosion of population is mainly responsible for more consumption of resources. More consumption of resource means we damage environment. Other thing that we need to mind is, we talk about environment, we talk about weather, we talk about climate. So weather is all about the current atmospheric conditions, that is temperature, precipitation. Precipitation is rainfall, wind, humidity, atmospheric pressure at any time, at any given time. For example, if you want to express any of these things today, or today weather is so and so, we say. Whereas climate, though concern these things, is different in terms of long-term weather conditions are called, or is called rather, climate change or climate. So a weather that is measurable for 30 years and a drastic change or some change that we can see in weather for 30 years period of time is referred to as climate. So today we see a lot of changes happening in our climate. And mainly these climatic changes are brought in the atmosphere. So in the atmosphere, this is how our atmosphere is divided as troposphere, tropopause. This is where the ozone layer lies at about a depth, at a height of 20 to 30 kilometers from the surface. Stratosphere, like that, different spheres have been divided in the global atmosphere. So this, our atmosphere is filled with about 78% nitrogen, 21% oxygen, and all other gases put together, including carbon dioxide, methane, nitrous, etc., constitute just 1%. So The main issue happening is here. That is, this climate is affected continuously, leading to climate change. Some of these things. Okay. So we should know what is happening to climate. So we know that atmosphere is getting warmer and warmer, which we call global warming, because there are lots of pollutants, and these pollutants are affecting ozone layer. So all our spheres of atmosphere, hydrosphere, biosphere, geosphere are affected, leading to climate change. If you look at this diagram on the right side, you can see that since 1940, on an average, this was the trend of the global temperature. That is -2, -4, -6, like that. Temperature was witnessing lesser degree of warming. So in 1880, 1890, you can see temperature was maintaining its balance, more cooler. Whereas 1940 onwards, there has been a steady increase, 0.2, 0.4, 0.6, 0.8, 1 like that. So global temperature is increasing gradually. Just a minute. Yeah. So when we know that there is a climate change happening, we should also know the possible impacts due to climate change. We all know this. Cyclones can be resulted by climate change, floods, droughts, sea level rise, ice ages, landslides, avalanches. And as a consequence of all these things, economic disasters and many related hazards are possible. And the big question now we face is whether, if at all, human life comes to an end or human species become extinct, it can be probably due to the climate change and its hazard. The next question is, whom to be blamed for climate change? Is it we? Is it man who has to be blamed? Probably yes. Still, we are not very sure. Recent anthropogenic emissions of greenhouse gases, as estimated by IPCC, Intergovernmental Panel on Climate Change. It's an international body. So they have measured that carbon dioxide has been increased by 29%, methane 150%, nitrous oxide by 15%. So as a result of these three principal gases contributing, we see that from an industrial era is said to have begun with 1850 time. At that time, global temperature was 13.6 degrees. Let me also say a few things. That global temperature, when we say, is a mean global temperature. Temperature may be 0 at polar regions, and it may be as high as 45 degrees in the equator in some parts. So all this put together to refer as mean global temperature. And that was 13.6 degrees at the time of industrial era, and now it has come to 14.3 degrees centigrade. A very clear 1 degree can contribute a lot. And this 1 degree is expected to rise by another 1 degree by the end of this century. So around 2000, around 2100, we are likely to experience about 15.5 degrees centigrade temperature increase. So this figure from NASA shows that for millennia, atmospheric carbon dioxide had never been above this line. This line is 300 ppm, parts per million line. So in the past 1 lakh year, 2 lakh year, 3 lakh year, 4 lakh like that, 8 lakh year, if you go back, the temperature never rose beyond 300 mg per liter level. But now in 1950 onwards, it has risen to about 380 or close to 400 ppm level in the atmosphere. That is the real concern. Supriya, these titles are obscured by the top thing. Is it happening there also to you also?
No, but there is a long history for
You can read
climate
it, huh?
change. It's
You can-
visible, sir.
you
Yes,
can-
sir. Yes, sir.
Okay, then, fine then. So
Okay, sir.
now, if you look at climate change, only geologists and archaeologists and those who are interested in the past can only know that climate change is not only today's activity. Climate change has been active since millions and billions of years. See, global climate has varied since the most primitive atmosphere. So most primitive atmosphere developed way back about 350 crore year back or 3.5 billion year back. So we have a very long history. So how do we know that man has been there on earth only about 20 lakh year back? Our existence is just 20 lakh years. Whereas earth has got a history of 450 crore year or nearly 500 crore year. Man never existed. Still we talk about that. So the proof that climate change occurred even in the past is recorded in what are known as sedimentary rock. Sedimentary rocks are those rocks which are deposited under water. So these have been preserved and they provide a lot of evidence to us. About 4 billion years ago, the early atmosphere had a composition like this. 4 billion means 400 crore years back. We had only this carbon dioxide, water vapor, nitrogen. They were the principal gases in the atmosphere. And minor gases were hydrogen, hydrogen chloride, sulfur dioxide. At that time, virtually there was no free oxygen. Whereas now, free oxygen is about 20% in the atmosphere. At that time, no free oxygen. So, we have the records, geological records. If you look at these pictures, these are called single-celled organisms that are found in sedimentary rocks. They are called blue-green algae. These blue-green algae have been preserved in rocks, especially in sedimentary rocks. And these are the rocks that we see present today. These white structures are called stromatolites, a kind of early species that were formed about 3 billion year or 300 crore year back. This kind of organisms lived in the rocks, lived in the oceans, and they have been preserved in the sedimentary rocks. And these are all the structures you can see to indicate that the past organic activity was existed even in those time oceans. So we understand that in the past, when man was not there, when so many types of animals were not there, single-celled organisms were present, and they sustained without oxygen. Okay, they only absorbed carbon dioxide that was available in the atmosphere, that was available in the dissolved form of ocean water, and secreted the sunlight. They broke CO2 into C and O2. C was consumed as food and O2 was liberated, and that gradually added up to make oxygen content in the atmosphere. So this diagram depicts us how the oxygen developed in the atmosphere. You can see 0, 20, 40, 60, 80, 100. This is cumulative oxygen production. And this is billions of years of history. So if you see today is the present. And if you go back in the history, geological history, 1 billion, 2 billion, 3 billion, like that. So by studying the sedimentary rocks, you will see that there was very little atmosphere at that time. Between 2 billion year to 4 billion year, virtually no oxygen, very little oxygen. From 2 billion onwards, slowly oxygen increased in the atmosphere, make it 20% today. So geologists have the evidence. Evidence for atmospheric evolution comes from the geological record. You can see, have you, any one of you, have you seen this kind of rock in your villages or in your places, in your areas where you got hills or some other things? They are called rocks called banded iron formations. Very beautiful layers of red mineral called jaspilite or jasper. The block layer is called iron. Iron quartz. Iron is Fe2O3. This quartz layer is SiO2. So these alternate layers of iron and oxygen have been deposited under ocean during a time when there was very little oxygen available. So that is a period until about 2.5 and 2. Giga Annum, that is billion years, or 250 to 200 crore year, there was not enough oxygen in the atmosphere to oxidize iron minerals. So oxygen dissolved in the oceans, oxidized iron to produce marine banded iron formation. So whatever little oxygen that was available was consumed to make this iron formation. And this constitute the big iron ore deposits for us. Okay. And the right side figure, image, is also iron formation, not much of iron, but they are called continental red beds. And such continental red beds are formed when there is abundant oxygen available on the surface. And this oxygen accumulated in the atmosphere to oxidize iron on the continents and to make the first red beds. So banded iron formation and red beds are very clear indications of the evolution of oxygen in the atmosphere since thousands and thousands of years geologic time. Not just oxygen content varied, even the geological record has also indicated temperature regimes changed a lot. Of course, you may not be very well versed with this kind of names. It is the geologist's domain. The earliest period in the Earth's history is called Precambrian, and the youngest history is called Holocene. So from 450 crore year to 0 years now, we have seen the temperatures varied a lot. So this was a period called Cretaceous. You can see warmer than present, colder than present. So in Cretaceous time, the temperature was over 15 degrees, much higher than today's. What does it indicate? Climate change was happening even at that time also, when man was not existing. So wide range of climatic conditions prevailed, and radiative forcing due to a variety of causes has been postulated for many extreme climatic events. Radiative forcing is the amount of sunlight received to the amount of sunlight radiated back to the atmosphere. And the Cretaceous period was the warmest period that we have recorded so far in the Earth's history. And why this kind of situation prevailed and what were the consequences of that? If you can visualize that, a temperature of more than 5 degrees warmer than today means a bigger temperature where all ice caps melted. No ice caps, sea level was higher, and followed by that in the period of Pleistocene and Holocene, where the temperatures brought down to less than 15 degrees centigrade. The glaciation, that is large-scale ice formation, occurred. What I'm trying to say is that climate change, you should know, is not just because of human activity. It can happen, it could have happened even in the past also. So you are all very familiar with these gigantic animals. As a result of this climate change that occurred in the past, these huge animals, which we call dinosaurs, all became extinct. In the geological past, there were 4 great periods called mass extinctions. One was during Ordovician and Silurian, about 438 million years back, or 43.8 crore million years back. Another period called Late Devonian, Triassic, Jurassic, Cretaceous. So during this period, mass extinction occurred. Mass extinction means all those living beings that survived at that time came to an end. So this large-scale perishing or large-scale loss of life can only occur because of the climate change. That's why I said, if at all human race comes to an end, it could perhaps due to the climate change, because you can do anything, you can adjust your life to anything, but you cannot adjust to a global scale climate change. These are all the different types of dinosaur animals that lived at that time. And this is a picture showing geologists in some of the Argentinian terrains scooping the ground for the fossils. This kind of animals buried have become fossilized. They are studying those fossils there. So, climate changes and the consequent weather impacts which cause cold periods, warm periods, drought conditions, etc., are largely influenced by natural phenomena, and they operate in large cyclic period. And these large cyclic periods may involve millions of years, or sometimes thousands of years. Geological processes are not in equilibrium. That's why this climate change occurs. Equilibrium means any situation remaining there for long periods unchanged is an equilibrium state. But geological process never occur because Earth is a dynamic system. There is a lot of heat generated inside, and that heat is dissipated outside, and as a result, we get lots of changes. Geologic processes are one set of drivers for climate, and therefore, climate cannot be in equilibrium. This theory many people don't appreciate because they want to say that climate change is only because of human activity, which is not true. So this makes assessing any cumulative human impact on climate difficult. At the same time, it is impossible to prevent this natural process. So when the temperature or any other process operate in a global scale, impossible to measure their activity, impossible to measure the dimension, the scale in which they are operating. Neither we can stop any of these activities. So when it is almost impossible to prevent the natural process, at least we can minimize human impacts. This is the crux of the issue. Means that we know for sure that natural processes do operate and bring changes. Human activity continuously also affect climate change. We cannot control natural process, but we can definitely control human activities. That's why it is very important to know that human activities through human modifications or bringing changes in our attitudes, we can to some extent control climate change. So human contribution to climate change is one of the hot debate topics today. And as I told you, the global population, increase in global population. And another important thing is shift in agrarian activities to industrial activities. Today, everyone wants to live in cities. They are slowly deserting villages. Agrarian or agricultural activity is becoming lesser and lesser attractive. Urban expansion are happening. As a result, there's a lot of demand on resources. And all these things ultimately lead to demands which are ultimately energy-centric activities. So if you take anything in the city, nothing moves without power, without current, or without one or the other kind of power, no activity is possible. Therefore, that is the actual issue now bothering us. So all are energy-centric activities. Once they are energy-centric, we look for energy resources. So more you consume the energy resources, ultimately we produce harmful additions to the atmosphere. Once you produce or add harmful additions to the atmosphere, automatically environment is affected and long-term climate changes become imminent. Which are the gases which are really causing the so-called global warming? Globe is warmed up, heated up. Which are the ones? Carbon dioxide. So about up to 55% is credited to carbon dioxide for the global warming. Its concentration is only 355 ppm in the atmosphere. Methane, about 18%. Nitrous oxide, 2 to 6%. Chlorofluorocarbons, 24%, plus some water vapor, sulfur dioxide. So all these things are causing this atmosphere polluted. And we quite often talk about holes in the ozone. This is the ozone layer. So you go up about 20 kilometers, you encounter with ozone layer. So once this hazardous gas reach there, they make holes there, allowing harmful ultraviolet rays to reach the earth. So for having said that, the energy sector contributes for the highest global warming. It is very important for us to understand. Supriya, how much time you give me?
Sir, five more minutes. Sir.
Oh, then I will have to just touch upon the title. So energy sector contributes to the highest global warming. And which are the energy sector? Coal, natural gas, oil. They are the ones which are causing, and they are the ones which the world over people are crying to stop consuming. And the demand for them has been steadily increasing, that we need to stop. And fossil fuels are petroleum, natural gas, and coal. These are all called fossil fuels. They are accounting for 73% of greenhouse gases. We just discussed greenhouse gases, that is carbon dioxide, methane, and others. So they are mainly produced by burning of these gases. Paris Agreement very clearly says that we must bring back our present day 14.5 degrees temperature to 13 degrees, then only it is possible to prevent climate change, but it appears to be a big task. And having said there are so many problems, that is a futile exercise. We must also have remedies for that. What are the remedies that we have at our end to prevent this global warming? It is mainly by reducing the usage of fossil fuels. So you must find alternate sources. What are those alternate sources? Nuclear mineral source as a fuel, nuclear mineral fuel to generate energy. Lithium mineral source to store energy. Lithium will not produce energy, but it can store energy. And gas hydrates are another source. I'll just provide you a glimpse of that. Nuclear energy is, we are far behind. You can see that France is getting their energy requirements up to 72% of nuclear energy, whereas India is just 1%. So there is plenty of scope for us to generate more nuclear energy, which is a green, clean energy, and we can bring about burning of fossil fuels and can contribute in controlling climate change. This is a ore which is called pitch blende, uranium bearing ore, which contains U2O3, uranium oxide, in which you got an element called U235, which is mainly used in all our nuclear reactors to provide energy, to to generate electricity. And these are some of the statistics to show that we need to generate we have plenty of scope. In India, we have lots of potential to generate nuclear energy. But right now we are importing from Russia, Kazakhstan, France, Australia, Canada. They are our main suppliers of nuclear fuel. So there is we can produce a lot of nuclear resources to reduce coal burning. The big question, the doubt must be lingering in your minds also, that it is hazardous. Nuclear energy is hazardous, but it is not hazardous if you handle it carefully. If you look at this picture here in this, so coal burning will account for this loss of so many estimated impact of fossil fuels and alternate energy sources. This every human figure that is indicated here is equal to one animated figure here indicated to 10 years of life lost per trillion kilowatts of energy. So if you use 1 trillion kilowatt of energy, coal will affect the life of so many people. Natural gas will affect the life of less people. Wind will very less. Nuclear is the least. So what we need to know that nuclear energy is still a clean energy. No doubt around the world lots of nuclear reactors are closed because of the problem in handling them. But there is always a remedy. When compared to the dirty things that we are getting out of the coal burning, this is definitely better. Gas hydrates are another great source of energy that we have got hidden beneath the ocean, about 1,000 meters below the ocean bed. We have what are known as gas hydrates, which are nothing but methane gas hydrates, they are like this. Can you see the last picture? A clear salt-like crystal which can burn on its own. This is called a gas hydrates. It's a huge resource waiting to be harnessed. If you look at this picture, you will come to know. This blue color is all the energy available in the form of gas hydrates. And this is all the energy mainly by the conventional fossil fuel energy. So the energy in the form of gas hydrates is enormous. We still to harness it because there are lots of problems in its exploration and also exploitation. These are how the gas hydrates look. And this is how globally these gas hydrate deposits are distributed. These red points, red and blue, you can see, India too has some of the resources that are available, and exploration is going on. Next is lithium as alternate clean energy. It is not as a directly energy, but it has got an energy. It has got abilities to store energy. Therefore, all our transport mode run by petrol and diesel are going to see very soon, at least in 2 decades, completely the end of the day for them. And we will be replaced by electric vehicles. And in all electric vehicles, lithium is one of the chief metals that is being used. And that's how a lithium metal looks. And this is how a rock consisting of lithium oxide appears. And there are different sources, but sadly India is not having enough resources, explored resources. We need to explore them. And now, of course, this is the main country. That is, South America is contributing for huge deposits of lithium. And China is also one of the big countries that is all set to export. And most of the other countries are importing because in Europe and America, we see the boom in the manufacture of electric vehicles, but they are not producing. And those who are producing can command a very beautiful price for them. And in India, lithium import, you see in India, it has from 1.2 billion is the present import cost from 384 million in 2017. So it is going to increase. India has got, in Karnataka, we have some of the lithium deposits, but not big deposits to mine and to produce, but still efforts are on. So addressing energy sector can greatly help in reducing the impact on environment. One of the other facts, other human activity that causes a lot of environment pollution, and in the long term, climate change is solid waste management, which is another big area that we need to address. It has got advantages also. We can harness energy through that also. It's another area of concern. So basically, we need to have a change in human attitude. That is, think globally, act locally. That is the present day slogan. We all normally think that whenever there is a problem, we say ourselves that, oh, what if I alone do, how I am going to contribute, how I am going to be helpful, like that. That attitude should go. So even at an household level, we can contribute in one way or the other to prevent the pollution of environment, to prevent global warming. So I see many houses, people don't care if fans are running, lights are burning. Is it not going to cause, even in a small scale? There is some big factory working, burning coal to produce your electricity. Like that, there are hundreds of ways through which we can definitely act it at our own level, and that can contribute slowly but steadily to the global environmental protection, and that prevents the impacts on climate change. That's why we must have a very broader perspective. Think very big way globally. Act in your own small way. That's how a new word called global has been coined, merging global and local, global and local. So we come to the summary of this talk. As long as humans thrive on Earth, the environment will be getting affected, though on a small scale, but they contribute, not on a small scale, though on a significant scale, but they contribute to the climate change. Natural geological processes do contribute to climate change, but it is difficult to quantify the process. For example, a volcano can give out millions of tons of carbon dioxide somewhere, but it's very difficult to quantify how much of carbon dioxide has been emitted. That's what it is said. Geological processes are operating, but it's very difficult to quantify their process and to quantify how much of pollutants are added to the atmosphere. Since the climate change threatens the very sustenance, it is of paramount importance to suppress the carbon emission and prevent global warming. And technology can greatly contribute. Of course, now you can see the electric vehicles, that's a technology. And so many, every day there are different things are coming up. That's a good sign. Future for the hope for future, the hope for the earth. Thus, environment and climate change are inseparable and intricate entities, and hence be tackled together. So, you protect your environment, mind your environment, mind your activities, that in a greater way will have a positive effect on climate change. Geological knowledge and investigations are vital for sustainable management of climate change, energy, environment, and hazards. Therefore, not because I'm a geologist, I'm telling this. It is very important for everyone. We should know that after all, we live on Earth. So, Earth science, geology is the one which provides a fundamental knowledge about the activities that are taking place naturally. And unless we know them fully well, it is not possible to control our emissions. And also, it's not possible to really do anything good for climate change measures. So, this is what I wanted to share with you. Thank you.
Thank you, sir.
Yeah.
If you have questions, you can ask, sir, and everyone. You can unmute and ask your doubts and clear your doubts. Any questions? Okay. No questions from audience. Sir,
Okay.
what is the present scenario we are facing very intensively regarding this climate changes? Sir?
The important thing is that rise in temperature.
Mhm.
The big concern that in all the environmental summits that are taking place in, whether it is in Kyoto or in Tokyo or in some other European country, every year they're taking place. The thing is that pre-industrial era was having a temperature of 13 degrees. So about 150 years afterwards, the temperature has gone up by 1 degree. That is now 14.4 degrees centigrade. This is the main crux. So this temperature increase, one aspect. And the second, emissions, carbon emissions. Carbon emissions are mainly from the industries and automobile industries. So these emissions, burning of fossil fuels, and even to generate electricity, we are burning lots of coal, at least in India. Lots of coal, billions of tons of coal is burning. So this fossil fuel consumption on one hand and relentless increase in the temperature. These two are the burning issues right now the whole globe is facing, more so in India.
Okay. Any questions? Okay. Bhumika?
Ma'am, I have one doubt. Yes, ma'am. Can I ask, ma'am?
Yes, Bhumika, you can ask now.
If we are burning more fossil fuels, the global warming will increase. So for that, now everyone is looking after production of biodiesel. So even though from that biodiesel, methane gas will be produced now in that agriculture fields.
Yeah.
This I have a question, sir, because methane will be produced more from agricultural fields.
Yeah, you have a point there. See, biomethane or biogas production is not happening in a big way that is expected of. For example, all the unconventional energies that energy that we are producing hardly contributes for 10%. Remaining 90% is coming from fossil fuel burning. So that's what I was telling. Even if you municipal solid waste, the garbage that we throw every day in our homes, and that is collected by BBMP municipality, and they throw without much care. Even if you convert that garbage waste, you can produce a lot of biomethane. Okay. In Switzerland, I think Switzerland or Belgium, there was a minister who had visited India, and at that time there was a lot of waste problem in Bangalore. So she asked sarcastically the people, if you have so much of waste being wasted, you give us, we need your waste. Because they are burning, they are harnessing their waste is to such an extent that they don't have energy problem. At the same time, they don't have the waste problem. Whereas in a city like Bangalore, we have lots of litter waste thrown everywhere. At the same time, we don't have enough power supply. So why don't we do that? Your point is right. So both in agricultural sector, we can generate a lot of biomethane or biogas. And in cities also, municipal solid waste can be converted into produce methane gas. But it is happening, but it's in a very, very small scale. When it is happening in a big scale, we are contributing to a greater extent to prevent this climate change.
So from this municipal solid waste, the diesel will be alternative for that fossil fuel, sir?
It is not diesel. It is not the diesel production. You can produce from biomethane. You can produce any sort of usable gas. We have actually worked out a scenario where nearly 300 tons of biomethane gas or biogas can be generated, like the gas we use at our homes. Similarly, we can produce gas from this methane gas, municipal solid waste, and it can be converted. But that conversion technology, though it is available, it is not effectively implemented. And waste sorting is not happening in a proper way. So when they do happen, to a greater extent, we can convert this waste into some utility.
Okay, sir. Thank you, sir.
Yeah.
Any questions?
Hello, ma'am.
Seema?
Yeah, it was a wonderful talk and I enjoyed it a lot. Thank you for the wonderful information.
Can you speak some more louder?
Can you hear me, ma'am?
We are not hearing. Hello?
Yes, ma'am, now.
Sir, are you able
no,
to hear?
No, not clear. Not clear. If you can hear,
Can you write in chat box?
Okay. I'm
Is-
using the mic now.
now
Can you
yes.
hear me, ma'am?
Better.
Yes, yes.
Okay. It was a wonderful talk, sir. Thank you so much. I got to know so much information. I'm currently pursuing my full-time PhD in meteorology.
Very
I
good.
just wanted to ask you one thing. This environmental science or meteorology, actually everything is co-linked and everything is related.
Yeah.
As we are now, for the future generations or the students of the schools and the colleges, what would you like to tell them? Or because there is so much drastic changes and so many people, researchers are doing on this. So to pass the message for common people in the society, it could be done through schools or colleges. What could be your words?
You see, if you remember the last but one slide, think globally, act locally. See, we all do different profession. I may be a teacher, you may be a student, some may be a fitter, some may be an auto driver, some may be a car manufacturer. We all do different business. So in everybody's mind, it should linger. Okay, the environment where I am working should not be affected.
Yes, yes, yes.
Should not be polluted. So what best you can do to your level? You can prevent water pollution, you can prevent air pollution, you can prevent solid pollution. Like that, there is a way out. So this attitude and mindset should be inculcated from the childhood itself, from school level itself.
Yes,
Everybody
yes.
should, this is how, you must have heard about the Thunbergs, the young girl who has made news in recent times
Yes,
because of
yes,
environment.
yes.
So this kind of attitude in us, in our small effort, we can definitely contribute to
Okay. No,
prevention.
actually, why I asked you, sir, I was teaching for BSc and MSc students past 4-5 years. Then from past 3-4 years, I'm doing my research. What I found was like some science students are aware of it, but when I see some commerce or art student, I feel regarding about the waste or regarding about the global warming, etc. Maybe some students they think, but something should be done for all. Like it should not be only for science students or something. So what could be your?
Definitely, it is not just for sins because there
Yes,
we are not even half of them. Okay.
Yes, so only they are not aware of it.
They are aware of it. Only thing negligence. A kind of a general way or attitude in all of us, not just there. In all of us.
I agree.
So when I go out, if I look around and if nobody is watching, I'll just throw my litter there. Isn't it? So that basic instinct should prevail in us. That consciousness prevail in us. And above, at school level, catch them young is a word, we should make the students think about and inculcate. We should create that interest or kindle the interest in them that environment, pollution, global warming, it should always be there in all our activities. Then some kind of, awareness, some kind of awareness in our acts, day-to-day activities will prevail. That in one way or the other help people grow and contribute in one way or the other towards this pollution-free environment.
Yes, sir. Yes, sir. Thank you so much, sir.
Yeah, thank you.
Thank you, ma'am.
Okay. Any more questions? Okay. I think we wind up here, sir.
Sure.
So thank you very much. It's a wonderful talk today. We should aware of small things and big things also. So we have to keep everything which involves us to keep all the things in right way. So thank you very much, sir, for giving a spotlight to some extent.
Sure.
Thank you very much.
I also thank you for your interest and interest in bringing awareness to your students, your colleagues, and public in general. And I also thank all the participants for patiently listening and also developing some questions. And this lecture, if at all, triggered some thinking in them. I'm really happy about that. Thank you all.
Sir, 1 minute. Srinath, anything you like to ask, sir?
Me?
No, sir, someone raised hand. So I was asking. Okay, sir, we are winding here. Thank you, sir. Thank you.
Thank you.